So far, we've explored working with modules that we imported. These modules weren't created by us. We simply used them. We played the role of clients rather than creators. Now, let's dive into how we can break our Node.js programs into multiple files by creating our own modules. Instead of just being the clients, the code that utilizes the module, we'll also step into the role of creators and see how to actually use these modules. First, let's clear out all the files and folders we currently have, as we don't need them anymore. We'll also delete all of this code so we can start fresh. Let's begin simply. Suppose I have a function that we'll call test function, and it will just log a straightforward message. Naturally, we can call this function without any problems, and it doesn't get much simpler than that. Just defining a function and calling it. When we run this program, we should see the message displayed by the function. Now, let's say we want to structure our program differently. We want the functionality to reside in one file, while the usage of this functionality takes place in another. So, it's time to create our module file. A module is fundamentally just a JavaScript file, so let's create one. I'll name it utils.js, and this file will house our functionality. Here, we'll write the code that can be used in other files. The functionality we're talking about is our test function, so let's move it from app.js to our new module file, utils.js. Since this functionality will be imported into another file, let's update the message that our function will log to reflect that change. To be able to import any functionality from a module file, we first need to export it in the file. Only exported functionality will be accessible in the requiring file. The key distinction between modules and regular JavaScript files is that in modules, we export some functionalities, like a function. In this case, we intend to export test function, and we'll accomplish that by using module.exports. We need to assign what we want to export from this file to module.exports. Here, we're exporting our test function. Once we do this, we'll be able to use it in other files. Now, let's return to our app.js file. We need to require the module now. Specifically, we'll require the functionality we just exported from the module file, which will bear a close resemblance to how we required built-in modules such as the OS module or the FS module. But this time, we'll be requiring our utils.js module, the one we created. Once again, I'll define a constant to store what we require from the module. Since we're importing a function defined in the module, let's name the constant accordingly. This constant will equal require, and as a parameter, we'll provide the path to our utils module. Now, we can utilize the test function. Even though the test function was declared in the utils file and not here, we can still make use of it. When we run this program, we can see the functionality defined in the module in action. It's worth noting that in the module, the function is called test function, which is why I chose to name my constant the same way. However, we don't have to stick to this naming pattern. It's perfectly fine to rename the constant. For instance, let's rename it from test function to test function 1. This change will still work, but it's crucial to remember to use the updated name when calling this functionality. Also, we don't need to include the .js extension when requiring the file. It's completely acceptable to just use the file name, with .js being implied. Now, what if we had more than one function to export from the file? Let's say, in addition to our initial test function, we now have another called test function 2, and we want to export both. To achieve that, rather than exporting the functions themselves, we will export an object containing all the functions we wish to share. In this case, we'll be exporting an object that includes both test function 1 and test function 2. Since we're now exporting an object, it might make more sense to name our constant utils, reflecting the name of the module itself. This name indicates that we're not requiring a specific function, but rather all the functionalities from the module, granting us access to its various components. If we want to access one of the functions from the module, we'll write the name of the constant we defined, followed by a dot. As you can see, we can now access all the functionalities exposed in the module, including test function 1 and test function 2. Let's see if we can use test function 1, and upon running the program, we'll confirm that our first function from the module executed successfully. Placing both of the files side by side allows us to see the module code and the requiring code at the same time. We're not limited to defining and exporting functions. We can also define and export a class. So, let's wrap both of our functions in a class, which I'll call utils class, and this will include both functions. Instead of exporting individual functions, we'll export the class itself. Now, regarding the requiring code, I want to make it clear that we're requiring a class, so I'll rename the constant used to store what we require to utils class. This clarifies that we're bringing in an entire class. Once we require the class, we can create an instance of this class using the new keyword, which will generate an object of utils class. With this object in hand, we can access member methods, such as test function 1. If we run the program now, we'll observe the functionality defined in test function 1. It's crucial to understand that when we require a module, what we receive is not always the same type of entity. It can be an object, a function, or an entire class. One more point I'd like to cover regarding modules and requiring them is what transpires when we call a function inside the module itself. So, let's define a function. I'll call it amazing function, but this time, I'll call it within the module. Not only do I define the function, but I'll also invoke it. Naturally, I'll also export it. When we reach the requiring code, I won't perform any actions besides requiring the module. Once we run this code, you'll notice that the function executes. This demonstrates that when we require a module, we not only gain access to the functionalities defined therein, but we actually run the module itself. This behavior of modules can be a double-edged sword. At times, it's quite beneficial, enabling setup or initialization logic, but it can also lead to unexpected behaviors. We need to stay mindful that if we execute any functions or run any functionalities in the module, they will run immediately upon requiring the module.